Okay, this is the final study guide video to help you. So this one, little change. We're just going to have you look and see that the first one here without the letters, without the marks, that's the pre-image where it starts and it's going here to the image. So it's starting here, finish down here. So make sure you know that. Don't switch that up. So for this, I'm thinking do a reflection first. Either reflect over the x-axis or reflect over the y-axis. If I reflect over the y-axis, it goes right there where it's in green. If I reflect over the x-axis, it would be down here, equal distance. And then I could see from there, if I reflect over the y, it looks like a quarter turn, 90 degrees, quarter turn to the right. That is clockwise. Or if I did the reflection over the x-axis first, then I could see that it's a quarter turn to the left, counterclockwise. So you choose. I'm going to go the first one here. I'm going to say reflect over the y-axis. To get to here. And then rotate 90 degrees clockwise. That's exactly what I would write. If I did the other one, I would say reflect over the x-axis first, but then rotate 90 degrees counterclockwise. So pick one. All right. For this guy right here, again, know the basics. A right angle and a right triangle is not enough. It needs to be right angle plus some more. So that would always be a no. Rigid motion, sliding, yep, that's always yes. For this guy, angles, even if it did have sides in there, doesn't matter. For this one, either one, not giving you enough info, always no. And then for this one, if it's sides, that's good. But just know, if they didn't have sides there and instead had the word angle, then that would be no. For this one, looking at it, it says sides. Yay, sides, always good. Side, side, side. Enough information. That one's always cool. For this problem, again, know the major theorems, the good ones. ASA, SAS, SSS, AAS. Hypotenuse leg, really, or leg, if it's a right angle in there. The bad ones, ASS, AAA, which is not really bad, it's similar, but it's not congruent. All of these, that's me right. All of these are congruent. And then note the other ones. For the movements, only the rotation is good. All the other ones bad. Reflection, translation, and then dilation. Those are the. So for this, ASA, that's one of those I need to memorize. AAS, looks kind of like the ASS one, but it's not. Translation, that's definitely not rotation. Only rotation is good. And then there's rotation. All right, moving on. For this guy, know that this 2 tells you where to start on the y-axis, right here. That line, if I really graphed it, would have the same slope as that red line, but it would be going through 2 on the y-axis. Know that for this, the red line for this is the finish line. What I just wrote on there in blue is the starting line. So I know if it's starting at 2 on the y-axis and the new one has this 5 on the y-axis, that's going up by 3. And then if you had to explain that in words, that's what you would say. The original line, or you could say the pre-image line, starts at 2. Image line ends up at 5. Shift up by 3. That's something maybe you could write. Knowing that the starting one, that one I give you, g of x, that's the pre-image where it's all starting. The red one, f of x, that's the image after the move. And then technically, for those of you out there listening, this f of x line is negative 1/2 x plus 5. I get that by plugging this in to the transformation equation. Here's the transformation equation. F of x, that new one, came from the original g of x, but was moved up by 3. If I take this equation right there, whoops, not that one. If I take the starting equation, if I take that and plug it in the transformation equation right there, the slope will remain the same, but that 2 and that 3, those two numbers will combine to give me the new y-intercept. All right. This one, you know that for Mia, her rate of change, we're going to make this simple equation. Her rate of change comes from the number in front of that equation, in front of the n right there. That's how much she saves each month. For Carmen, to get her equation, I got to look at the change in the y data. This is y data versus the change in the x data. If I divide those out, that gives me Carmen's rate of change, how much she's saving every month. So if I divide that out, looks like her rate of change is 6. So her equation would be 6x to see how much she's saving each month. And then use these to answer these questions. Mia, plug in 10 into her equation. And if you get 100 right there, that's good. But you can see when I plug in that, I get 50. That's no good. For the next one, plug in 20 into Carmen's equation. But you can see on that one, when I plug it in, it doesn't give me 100 either. So that one would be a no. And then comparing ones, Carmen makes more than Mia, or saves more. You're looking at these numbers in front of x. If Carmen's number is bigger, that would be a true statement. If Carmen's number would have been 3 or 2, that would be false. But this, Carmen has a bigger number, true. Carmen and Mia save the same amount. Those numbers would have to be the same, both 6s or both 5s. That's not good. And then for this one, if I plug in to Carmen's equation, this number 10, does it give me that 60 number? Yes, it does. If I take that same 10 number, but plug it into Mia's equation, does it give me that 50? And that one does. That's a double yes. If one of those was bad, that would be a no. Last one. Repeat this same slope we've been doing. Over 1, down 2, over 1, down 2, over 1, down 2, over 1, down 2. Looks like I did one of those. 2, 3, 4. So I'm going to stair step with this one. 4 of those. 1 of those. 2, 3. And then when I do that 4th one, that's where my coordinate goes, right there. So I did that nice and neatly. Starting from C, over 1 up to 1 of those. Over 1 up to 2 of those. 3 of those. 4 of those, right there. So that point is 2, 6. Make sure you write that the right way. If you mess up, that would just be terrible. Nice, neat, easy. Now the hard part. Show me all these coordinates and show me you can successfully use the distance formula. This one looks like, oops, that would be D up there, sorry. This one does look like a rectangle. So if I plug these values in, remember, these are the double negatives. Always on A and B, we've been practicing. So the length of AB, square root, that -6, subtracting a number already negative, plus, over here, doing the Y numbers, subtracting the number already negative right there with the Y numbers too. Those of you practicing calculators, you could type that in exactly. This gives me square root of -6 plus 2 squared. 2 plus 6 squared right here. That gives me square root -4 squared plus 8 squared. Looks like 16, not 2 times -4. 64. Add those up. Gives me root 80. So the length between A and B right here, 80. Keep going. Oops, sorry about that. All right, if I do DC, should give me that same length. Let's do that right away. So DC looks like, I'm going to go top to bottom, doesn't matter which order. 6 minus 2, I could have done 2 minus 6. -2 minus 6 right there. It would have been tough. If I subtracted up like that, that would have been a double negative there. It's tricky. Gives me 4 squared, -8 squared. That's where the 8 comes from. Gives me root 80. All right, doing the rest. If I do BC, let's see what that is. Ooh, there's the double negative for BC. Tricky. Oops, jumped the gun there. And then, oops, oh, disaster. And then the very last one. Looks like this is a true square, not a rectangle. That's okay. If I do AD, don't do a diagonal. Don't do from like D to B or something like that. Don't do a diagonal. So my last one, AD. All right. Hopefully this helps.
Good luck.